Now I just want to touch on something that's very practical when you're dealing with language models. We're going to count up a bunch of stuff and then we're going to divide it by some other things. And what very often happens is that these estimated probabilities can become quite small, especially if you have a very large vocabulary. If there's many different word types, then the probabilities can end up being quite small. And what happens in a language model is we're multiplying all of these things together. And the problem is you're multiplying together a whole bunch of things, all of them smaller than one. Maybe some of them are much smaller than one. And you can end up with very, very, very tiny numbers, okay? And a computer might even struggle to represent those numbers. So you basically get what we call underflow because the numbers are getting so small. One solution to this is to, instead of working directly in the normal probability domain, is to work in what we call the log domain. And the benefit of this is that the product of a whole bunch of probabilities, when we take the log, that product becomes the sum of the logs. So we have the sum of the first probability, the second probability, third probability, and fourth probability. And that's really neat because now if you multiplied all of these together, that might have been a very, very tiny number, maybe something that's difficult for a computer to represent. But if you take the log, it can actually represent that. But more importantly, instead of having to ever calculate that product of all these small numbers, you can take the sum of the individual logs. And this solves this underflow problem. So to calculate the probability of some sentence, W1 to capital T with an n-gram model, instead of multiplying together the individual n-gram terms, we're going to take the log of this. So we have the log of the probability, and here we've got the log of a product. And the neat thing is the log of a product becomes the sum of the logs. And then you've got these individual terms that you can just sum up and you don't run into underflow problems. Okay, so let's just look at one little example where we can actually see that these numbers can get quite small. So let's just pretend we have a P1 of something like that, a P2 of maybe that's a slightly bigger probability, P3 of 0.05, and then a P4 of, okay, let's make that slightly bigger again. Then if you multiply these together, you actually end up with a pretty small number, 2.5 times 10 to the minus 8. So that's 0.00000, a bunch of zeros to 5. And these are just 4 probabilities. If you've got a sentence with 10 words, then you're going to multiply 10 things together. And very quickly, you're going to run into underflow problems. Now, the nice thing is if we use logs, I hope I can import NumPy here. If we use logs, then these numbers become much more reasonably sized. Okay, so the log of P1 is that, the log of P2 is that, the log of P3 is that, and the log of P4 is that. And if we add them up, and this is taking the natural log everywhere, then you end up with a number minus 17. Okay, now e to the minus 17, that's pretty small, but at least your computer can represent it. So most often when dealing with language models and with all these counts that we need to keep track of, we do that in the log domain.